I think we can probably get going here. So welcome everyone. Thank you for being here. This is the first in a series, a 6-week series of colloquia following sort of this year's theme or format, where we're doing running themes over a course of many weeks. And this one has been put together driven largely by the EOAS Climate Emergency Committee with assistance from a number of other groups, both within and outside the department. So we're really excited about this one. And the theme of this particular series is really about highlighting not just the climate science that we all know and love, but the intersections of our science and what we do as our scientists with much bigger, broader aspects of the climate crisis that come across many disciplines and sectors in both society and in nature. So of course, there are some sessions, particularly the first few, that really focus in on a lot of the climate science aspects, but you'll notice that in this theme, and I'm just going to share screen here so that you can all see what we have in store. So hopefully everybody can see that. So we have this next 6 weeks, and there's a pretty broad range of topics, ranging from, as I said, some climate science to aspects of how we translate science into good social policy and planning. What are some of the justice issues that arise from doing both science and resource exploration, things like that, and how can we reconcile that with some of the needs of a coming renewable energy-based economy, for example. So there's a lot of these kinds of questions that we're tackling. A lot of this has come from just the recognition, as many of you will know, that these interdisciplinary aspects are really important and critical to addressing the climate crisis in general. And so there's a lot of emphasis on that idea of cross-disciplinarity these days. So that's really what we're getting after here. So I'm going to just turn this over to Stephanie, who's going to introduce today's speakers.
Great, thank you, Colin. Yeah, so everyone, welcome, Happy New Year. I'm really great to see so many people here, and I hope you can join us for the whole series. Today's theme is making research relevant in the era of the climate crisis, and I'd like to acknowledge my co-hosts, Annalise and Rachel, who have helped put this idea and theme together. How it's going to work today is we're going to have a series of 3 short talks by 3 visitors. So William Cheung, who's the director of the Institute for Oceans and Fisheries, is going to talk first in the first 15 minutes or so on the nexus of climate change, biodiversity, conservation, and aquatic food security. Then Rachel White from our department will go next and talk about what her perspectives on what research is needed now in the area of climate science. And then we'll follow with Sam Anderson, who's a PhD candidate in glaciology in our department, who's going to talk about deglaciation in Alberta and some of his experiences doing work in that area and interacting with communities. And then we hope to finish with some time left to have a bit of a broader discussion with the audience and the panel members about this theme of making our research relevant in today's era. So without further ado, I'm going to pass it over to William, who will take it away. Thank you. You have to unmute, William. Great.
I'm sorry. I don't know why. Like, we have done millions times of Zoom, and still I do this rookie mistake. So good afternoon. Before I start my talk, I would like to acknowledge that I'm living and working in the ancestral, traditional, and unceded territory of the Musqueam people. And I would like to also thank the organizer for the introduction, as well as for the invitation to this very interesting and meaningful meeting. In my talk, I'm going to present some of the works that I've done, as well as using that as an illustration of the research topic that I think are important in understanding and addressing the linkages between climate change impacts in the oceans, biodiversity conservation, and aquatic food security. Carbon dioxide emissions from human activities are affecting the ocean. And we know that the oceans have been doing a good job in helping us by absorbing over 90% of the added heat and over 20% of the carbon dioxide that we emitted. But in doing so, the ocean is also changing substantially, with ocean warming, loss of oxygen, ocean acidifications, and many other changes that the ocean is suffering. This year, the ocean heat content has reached another high record, and we are facing increasing intensity and frequency of marine extreme events. These changes are impacting marine life that are very important for human communities, as they provide us with food, with the things that support our livelihood, as well as are important part of our culture, and particularly for indigenous people. Recent international assessments also highlight that climate change is one of the main drivers of declines in biodiversity on land and the oceans. It also interacts with other human drivers, both directly and indirectly, in impacting biodiversity. And these impacts have already created barriers for us to achieve the sustainable development goals that we aspire to achieve by 2030. And on the top of that, climate change are also intensifying the social inequity problems that our society is facing, as climate change are felt differently by different countries, communities, and sectors, and often those who are most impacted have contributed least to the climate problems. My research studied the impacts of climate change on marine biodiversity and dependent human communities. In doing so, we try to find solutions to address this impact, and particularly our research used scenarios and models as methods and tools. We need to understand and elucidate climate impacts, the risk and vulnerability associated with that, and explore pathways to alternative futures, particularly to futures where we all desire. We know that climate change are already impacting marine ecosystems from the base of the food web to top predators. And that model simulations are projected that these will continue in the 21st century. These are projections from the ensemble of Earth system models and marine fisheries and ecosystem models projections, synthesized under the IPCC Special Report for the Oceans and Cryosphere in a Changing Climate. The models that my team and I developed also contribute to these ensemble models. And I'm also a coordinating lead author for the IPCC report. Overall, the net primary predictions that we project is to be decreasing, particularly in the tropical oceans. Also, with ocean warming and the associated polar shift in species, biomass and potential fisheries catches are projected to decrease in tropical oceans. These projections underscore also the global disparity of impacts as a result of the characteristics of differences in climate hazards and sensitivity that different regions are facing. And in fact, this is quite common in many aspects of climate impacts. One of the challenges in understanding and projecting climate change impacts is dealing with the emergence of what we call novel habitats. Many methods that are developed to assess and project climate risk and impacts rely on the assumptions of past observations and relationship between populations, species, and communities, and their association with their current or past habitats. However, climate change is going to create new environmental conditions that characterize the habitats that biodiversity have not experienced before. And this creates a scientific challenge to understand how biodiversity may adapt and adjust in these novel habitats. For example, in this study that's led by Gabriel Wigendor, a research associate in my research team, he used available model projections on ocean variables that are known to be influential for biodiversity, such as temperature, oxygen, pH, primary predictions, to project how biomes in the oceans would change in the 21st century under climate change. And we find that novel biomes will emerge in this as soon as this decade and expand rapidly. depending on greenhouse gas emission scenario. These novel habitats or biomes are largely concentrated in tropical oceans, particularly the South Pacific, Indo-Pacific, and West Africa, and that actually contribute to the large impact on marine ecosystem that we projected in the earlier results that I showed you. Another aspect of climate impacts is that it not only affects people or biodiversity, but that it also affects people who are dependent on these biodiversity for many aspects of their well-being. For example, climate impacts on marine biodiversity and fisheries are expected to affect human communities through the nutritional security. A lot of the focus of climate impacts on fisheries were on biomass, but in fact, it is the nutrients that the fish provides that matter more. Some of the coastal communities get a substantial share of their macronutrients intake from seafood, and without that, their health would be at risk. These are the projections from modeling works that my team did, which shows that climate change is going to reduce the supply of many of these essential macronutrients that are currently available from fisheries. And when we break this down to region, the tropics are projected to have substantially larger declines, and I'm going to show you in the subsequent slides. What's the implications for the health of dependent coastal communities, and whether these communities can adapt to such decline in seafood available macronutrient supplies remain an important topic that needs to be addressed. There has been a lot of optimism of expanding seafood supply from aquaculture. We also look at these dimensions. Particularly, we look at how such optimism in aquaculture would be like under climate change in the oceans. Mohamed Oyinola, who was my PhD student and postdoc, did some groundbreaking work on modeling the future of mariculture productions in the future globally. Basically, what we find is that there is some scope to expand mariculture if we can mitigate climate change, but not if we don't. In fact, we will reduce our potential mariculture productions in the long term under the high emission scenario. And one of the reasons is that many of the fish farms that we are operating use open net cages. The farm species such as Atlantic salmon in our coast are exposed to warming, acidification, and changing ocean conditions that are similar to what wild species are experiencing. So the suitability of the ocean habitats to be suitable for them to farm these species are projected to decrease under climate change. When we combine these projected impacts on fisheries and mariculture together to see what would be like for future seafood availability to feed people, we find that seafood production potential would not be able to catch up with the increasing demand in many countries, particularly again to tropical developing countries such as Solomon Islands and some other countries in West Africa. In the left-hand side of this panel, those are the projected changes in seafood nutrients productions by fisheries and maricultures by different countries, ocean regions. And that the right-hand side is a plot of changes in nutrient availability against change in coastal populations. And those red dots under the dotted lines are those that have a deficit of changes in nutrient availability relative to their change in population size. Okay. Sorry, here we use so another aspect that I think is important to look at, and I know Rachel is going to address that as well, is the marine extreme events. And so far, the projections that I show you are all looking at mean condition changes. But then we also want to look at how adding extreme events impacts to all these effects of climate change on fisheries and mariculture would actually means for biodiversity and for people. So we develop integrated models and apply our integrated models to look at marine temperature extreme events. I won't get into the details about modeling work, but overall what we find is that marine temperature extremes basically amplify the impacts of climate change on fisheries and dependent human communities. And for example, for sockeye salmon, by 2050, we projected a loss of potential catch of 30% relative to now, and adding marine temperature extremes would double that impact. The next things that we want to answer is about the compound extreme events, meaning that they combine the changes of different ocean variables in extreme conditions. So not only temperature, but then oxygens and pH and net pile protection. And this is a work in progress. And so far, we are working on looking at the compound extreme events from marine heat waves and ocean deoxygenation, using an index that my postdoc developed called the Aerobic growth index, which look at the combinations of physiological demand of oxygens, underwarming, and ocean deoxygenation. And we are working on this in collaboration with Thomas Fuliker and his team at the University of Bern. And so far, I've talked mostly about the global scale impact, but in fact, the impacts are felt locally by different people. And for example, in our coast, we find that many of the fish and invertebrate stocks that are important to coastal First Nations in BC will be impacted by climate change. And we are now working with coastal First Nations along the coast to use our projections to support the development of climate adaptation food security plan for these communities. And it highlights the importance of bringing the science and scientific outputs and then using it to co-develop knowledge and plan, incorporating indigenous knowledge and local knowledge into it in identifying pathway that can deal with and adapt to these impacts. So in summary, the bigger game plan that our team is hoping to have is to use research in scenarios and models to engage with community partners to understand climate change impacts, as well as using these to help co-develop visions for the futures that we all want. And in doing so, this can help us identify levers, policy levers or local actions levers that would allow us to transform to something that is necessary to achieve a desirable, sustainable futures. So with that, thank you very much. And if there's time, I'm happy to answer any questions. Thank you very much.
Thank you, William. We have time for a couple questions. If you'd like, you can either burst or raise your hand. I guess I'll ask you one. What do you think is the best way to communicate your findings about the really big difference there is between the high-end scenarios and the low-end SSP scenarios to the communities that are affected by climate, by fisheries changes?
Yeah, I think it's a really good question. And I think it is actually a challenge because a lot of the time, these scenarios are talking about big scale global drivers that are not actually that relevant to local people when we talk about global population changes, regionalizations of the society, or the global politics, geopolitics. I mean, it doesn't mean too much when you talk about specific coastal communities. So the first step is often for us is to understand what the communities they feel are important, the drivers of changes for the future, and then work from there and see how the local scaled important drivers and important factors relate to some of those global drivers, and then use that as a point of engagement to bring in the global scale scenarios that link to the local scale scenarios. And I have to say, this cross scale scenario thing is actually quite a new frontiers in the scenario science aspect. So a lot of colleagues are trying to develop different ways to develop these cross-scale or multi-scale scenarios using various exercises, including different participatory or modeling methods.
Yeah, Philippe, do you want to ask your question?
I do, thank you. Thanks for the talk, William. This is a real kind of nuts and bolts question. You talked about developing so-called metabolic indices to make projections about changing habitat distributions for fish, for example. It's my understanding that there's a few different formulations that are starting to float around, different combinations of temperature and oxygen and different scaling factors. Can you say anything about the difference between the various indices that seem to be developed and whether you think they might project different patterns in terms of species distributional changes?
Yeah, so that's I think that's the question that exactly what Taylor had addressed in her PhD and is now also working on as part of her PhD postdoc. The index that we developed is similar to the one, for example, developed by Curtis Dutchin earlier on. But then one of the main differences is in terms of the kind of data or data that is needed to parameterize the index. Our methods would allow for a broader range of species that can be that would be applicable under the index that we used, because we use some proxies to be able to apply to even data limited species. And we also compare the results associated with the two indices, and we find that there aren't any qualitative difference in terms of the projected changes overall for large number of species.
Thanks.
Thank you very much, William. And now we are going to switch gear from the ocean to the atmosphere, and Rachel is going to present us her vision of how science can be relevant for society. Up to you, Rachel.
Thanks, Anais. Sorry, I just lost the unmute button for a second there. So yeah, I want to give a sort of slightly more broad talk about climate change and the role of climate science, and what research is needed now, my perspective, so the perspectives from a climate scientist. And I also want to acknowledge that I am a white settler on the traditional, ancestral and unceded territories of the Musqueam, Squamish and Tsleil-Waututh nations. And I'm working to learn from the worldviews of Indigenous peoples and the knowledges that they have from their stewardship of these lands. And so these figures are just showing the idea of this 1.5 degrees goal we have for not having climate change go higher than 1.5 degrees. And as we just saw in William's talk, that makes a big difference, this mitigation of climate impacts. And so thinking about this question, I'm actually going to start more with what do I think we actually don't need? And so here's just a summary of climate sensitivity estimates from 1979 through to the latest estimates that came out from the IPCC report this summer. And so there has been some progress in science. We have reduced the uncertainty around this. In particular, we've sort of reduced these lower estimate. And so we know it's unlikely, climate sensitivity is unlikely, unfortunately, to be one of these lower estimates. But in general, what we know now is very similar to what we knew 30 years ago. And that's not to say that all of the science that we've done in the meantime hasn't been useful. We've understood a lot more about the system, about the climate system, about the way all of the pieces interact and all of the feedbacks. And we also understand a lot more about what we don't understand. But I think a lot of these questions now are interesting for their scientific value. But thinking about what sort of climate research do we need in order to address the climate crisis, my answer is I'm not sure we need much more climate science from the perspective that I think of climate science. And so here's why. And so here we've got these warming projections based on, it was updated in November 2021 to take account of the pledges and targets that have been put in place by the latest Conference of the Parties that was held in Glasgow, where all countries came and pledged their carbon emission goals. And so what we see is that if we want to reach this 1.5 degrees Celsius limit, even the current pledges are not going to get us there. And we've got this huge gap that we essentially need to be decreasing our carbon emissions immediately and very strongly. And, you know, there was a bit of a dip last year because of the shifts in the global economy. but latest estimates, and this is an estimate because this was done in, I think, November 2021, so they were assuming values for November and December, but essentially it looks like carbon emissions globally rebounded last year after the 2020 dip. And so, you know, we haven't even started to reduce our carbon emissions, let alone at the rate that we need to do for this. And so from my perspective, sort of the idea of more climate science in terms of understanding climate sensitivity, we know enough at this point to know that we should be doing something. We should be doing something very quickly, and it needs to be a strong response. And so what climate research do I think we need? And so the first one is research on how do we reduce atmospheric CO2. And this can include reducing our energy consumption. It could include reducing our fossil fuel consumption by relying more on renewable energy resources. And the theme of my presentation really, and it was mentioned at the beginning, is that this is an interdisciplinary problem, and we are going to, the best solution to this will be completely interdisciplinary, and really involving scientists and researchers from across many different fields, including understanding sort of the psychology and the social sciences of how do people respond, and how do we steer society towards a reduced atmospheric CO2 world. And the other side of that is actually taking carbon dioxide, CO2 from the atmosphere and sequestering it into back into land. And so I think that that's sort of an alternative way that we may need, given the discrepancy between the pledges that we currently have and where we need to be going in order to hit this 1.5 degree and not exceed it. But then the second thing that I think is particularly important is research on the impacts of climate change. And so the other two speakers in this session are going to give some excellent examples of this. And so I've just sort of stolen one of the pictures from William's slides. And then this is a picture you'll see later on when Sam gives his talk as well. And so thinking about the impacts of climate change, both on, here we had on the aquatic foods and on ice volume in the Rocky Mountains and the subsequent river flow. But there are many different aspects of the impacts of climate change and how they intersect with societies, how they intersect with infrastructure. And again, this is an interdisciplinary problem, as William was also emphasizing. And so we really do need researchers sort of really working together to fully understand how all of these systems combine across both the natural world and the anthropogenic human and societal aspects. And then part of this impacts, and as William sort of alluded to, is the impacts of extremes. And so this is where a lot of my research now focuses. And so I don't think any of us who were living in BC last year need any introduction to the impacts that extreme weather events can have. So these are all from last year. We had this historic heat wave in the end of June. We then had a fairly extreme wildfire season. It wasn't one of the worst, it wasn't the worst wildfire season we've had, but it was one of the worst. And then in October, we had these devastating floods and landslides. And I'm not even including the fact that we had a tornado that touched down over the UBC campus. We had some really strong low pressure systems. But these are the ones that can, the heat wave, the wildfires and the floods can be more directly connected to climate change through just very simple thermodynamic influences. So as we're warming up the world, we are going to see more heat extremes. And this also means that more water is evaporated from the oceans. And so there's often more water in, or more water vapor in the atmosphere that can be precipitated out in these extreme rainfall events and lead to this devastating flooding. And so, as I sort of said, we've got these two sort of ideas of extremes that are pretty concrete in terms of we're going to see hotter extremes. And so these are just two figures, the second one I'll show in a minute, that were from the AR6, again, this IPCC report that came out in summer. So this is actually looking at an assessment of the observed change in hot extremes. So what we have already observed at this point, and confidence in the human contribution. And so this is just sort of a map of the world. And so we've got North America up here. And so not absolutely every region has seen an increase in these hot extremes, but most of the world has. And the ones with 3 dots show a high confidence in the human contribution. And so you can see a lot of the world has a high confidence that human anthropogenic climate change has already contributed to these hot extremes. And that is because of this very direct relationship between increasing mean temperature and increase in extreme temperature. For increase in heavy precipitation, it is more complicated because this is a slightly less direct connection. And so we've got this increase in temperature because of the Clausius-Clapeyron relation. That leads to an increase in evaporation and therefore to an increase in extreme precipitation. But because of the variability in precipitation, actually the confidence that we have yet observed a human contribution to this is lower than for temperature. But unfortunately, as we go into a warmer and warmer world, this is likely to get worse changes and more confident that human contributions are important. And so here are just some of the key questions if we're thinking about the research on impacts of climate change on extremes that I think are particularly worthwhile. And so the first one is, okay, we know this thermodynamic aspect. What about the dynamic aspect? What will changes in atmospheric circulation patterns or atmospheric dynamics do to extremes? Will it increase extremes? Will it decrease extremes? Does this depend on the region? But I feel like I've talked about this several times already to this department, so I'm not going to dwell on this for much longer. But this is just a figure showing meridional wind, and so the colors are showing meridional wind patterns during 3 summer sort of months or periods, including this last year where we had this extreme heat event, and the diamonds are showing where we had extreme heat. And so you can see there's actually a strong correlation between these 3 different months where we saw extreme events across the globe at the same time in different regions caused by this same atmospheric circulation pattern. But what other aspects are there? And so some other key questions. Well, one is like, how do weather hazards become disasters? And so this was an interesting article that was published very recently, sort of saying, you know, it's not just the climate that's causing these disasters. Disasters occur when these hazards, which are increased by the climate, meet vulnerability. And there are human-made components in the vulnerability as well. And there's a fair amount of human agency in order to proactively reduce these disaster impacts. And so this goes back to this idea that I've been saying that interdisciplinary research is really important. And so yes, there is a climate physics aspect to this, but that connects very strongly to other aspects of how we live and how we live in this world. And then this is something William also mentioned briefly, this idea of compound extremes. And so you can either have sort of 2 extremes at the same time, or the idea of extremes affecting other extremes. And so again, we saw an example of this in British Columbia last year, where we had this devastating wildfire season over the summer, which likely increased the probability of the landslides that we then saw in November when we had some very heavy rainfall. And so this is sort of a schematic of how when you sort of burn the forest, it changes both the topsoil and the structure of the roots. And I'm sure there are others in the department who can speak much more fully on this than I can. But this idea is very sort of well known that wildfires increase the probability of landslides if you then have heavy precipitation. And that's not the only thing. If you have dry spells followed by extreme precipitation, that also seems to be a strong trigger of landslides. And other ideas of this compound extremes, that when we have heat waves and wildfires, that is related to an increase in air pollution, both of those separately. The heat waves, actually because of the subsidence, often trap a lot of ozone close to the surface, which can be very bad for humans. And combine that with the concept that when you have heat waves, you're more likely to have wildfires and the smoke from that, all of these contributing to the impacts of these extremes. And then this is just sort of a schematic of these extremes. And so the idea of these compound extremes that can be compound or connected across either a spatial scale or a temporal scale. And so you can have flooding that extends over many kilometers. And the one sort of up here where we've got multiple breadbasket failure comes back to the atmospheric dynamics. And so here's a figure where actually this is showing that because of these waves that are shown in this sort of gray wavy pattern, you're actually quite more likely to have concurrent heat waves in these regions shown in the dark red at the top or the lighter red for different wave numbers. And so this is a smaller wave. And here that's put on top of where some of the major breadbasket regions of the world are, and so where a lot of crops are grown. And so this idea that actually if we had concurrent heat extremes across 3 of these regions, it could have a very strong effect on global crop production. And so lastly, sort of coming back to this idea of interdisciplinary research across multiple worldviews, and that includes the worldviews of Indigenous peoples. And so I just wanted to read out a couple of quotes. This first one from an article entitled "Why Traditional Knowledge Holds the Key to Climate Change." And Gleb Raid-Gorodetsky said, "With collective knowledge of the land, sea, and sky, Indigenous peoples are excellent observers and interpreters of change in the environment. The ensuing community-based and collectively held knowledge offers valuable insights, complementing scientific data with chronological and landscape-specific precision and detail. And moreover, Indigenous knowledge provides a crucial foundation for community-based adaptation and mitigation actions that sustain resilience of social ecological systems at the interconnected local, regional, and global scales." And then I just want to finish with a quote from a book that I have enjoyed, Braiding Sweetgrass. I know some others in the department have also read this, by Robin Wall Kimmerer, thinking about how we go about fixing problems that we have caused in nature, and thinking about the sorts of fixes that the Western viewpoint often comes up with, saying this kind of fix is at the core of the mechanistic view of nature, in which land is a machine and humans are the drivers. And in this reductionist materialist paradigm, an imposed engineering solution makes sense. But what if we took the Indigenous worldview? The ecosystem is not a machine, but a community as sovereign beings, subjects rather than objects. And what if those beings were the drivers? And I think we just have so much to learn from considering a different worldview, considering that what we sort of, many of us grew up with, the version of science that we think is the only version of science, is one version. And there are so many other perspectives. And if we really want to come together and solve this climate crisis, we really need multiple disciplines and multiple worldviews. And so thank you for listening. Thank you for your time. I think I've almost reached my 15 minutes. So before Anais jumps in and interrupts me, I'll just leave up my summary and sort of my thoughts and perspectives. Thank you.
Yeah, thank you very much, Rachel. Does anybody have one quick question? Because we are kind of out of that slot of time. I guess, Rachel, since we are almost out of time, I will save my questions for the end, and I will introduce Sam Anderson, who will talk to us about a very practical issue of communicating about the deglaciation in Alberta, in oil country, as he said, and has lots of, I lost my track. Policy or political implications. Thank you very much, Sam, for joining us today.
Okay, hi everyone. So hopefully you can see my screen and hear me. So thanks for the introduction, Anais. My name is Sam, and I'm a PhD candidate in the department working with Valentina Radic, and I'm broadly interested in understanding how climate change manifests at the community scale in terms of water supply. And today I want to spend some time to tell a story about lessons that I've learned through studying community scale impacts of deglaciation in Alberta, because I think that I've had both some success and some failure in producing and communicating results that I hoped could be relevant and useful for both policymakers and the general public. So today I'll just be sharing some reflections. I was an undergrad student at the University of Alberta in 2015 when Gary Clark and a team of researchers, including my supervisor Valentina, published this paper on deglaciation in Western Canada over the 21st century. The finding that really struck me was that 70 to 90% of glacier ice volume in the Rockies was projected to be lost. I was immediately concerned because I was living downstream of the Rocky Mountains. And really, this was the paper that brought me to UBC for my PhD, where I wanted to pursue these ideas further. What I learned is that the steps typically taken to figure out those direct impacts at the scale of communities generally goes something like this, where climate models will force glacier evolution models, which feed into hydrological models, which then output stream flow, which is then used to assess the community scale impacts. The Clark et al. Paper from 2015 really focused on getting to an accurate assessment of glacier evolution. And with this understanding of how glaciers change in area and volume through time, they could then imply that there would be substantial impacts downstream. And this was a paper that received a lot of media attention. And I learned through reading through and engaging with responses to the work that there were a few repeated perspectives that were often offered by, I'll call quote unquote skeptics. There were often responses that went along the lines of how climate models and all of these models are uncertain and we can't trust them, or they're wrong from the ground up and scientists are faking it. And also perspectives that, well, we knew all this already. We've been saying forever that glaciers are melting, so what's new here? And to me, hearing this was really concerning because these are not just people that are lurking in comment sections, or they're not just bots. They are people and they are voters. And frankly, we do see these perspectives reflected in government all the time. And so I wanted to not only study the community impacts specifically, but I also wanted to do so in a way that could potentially address these repeated concerns that I was hearing. I wanted my science to be made relevant to this community so that they could get on board. So Valentina and I developed a project that focused on these final two stages of the pipeline. We did not center around climate models, instead opting to analyze historical streamflow data in Alberta. By taking this route, I hoped that we could sidestep the repeated criticisms of those models and also get at new information to potentially get these skeptics on board. We first answered, how do glaciers control summer river flows? We developed an empirical model that takes the basin glacier area G, which is the percentage of the basin that's covered by glacier ice, and then used it to predict both the mean summer flow and also the interannual flow variability of rivers across the province. Then we could investigate where the largest changes to mean flow and flow variability would occur under deglaciation, essentially by setting G equals 0. Second, importantly, we then answered, where do people actually get their water from? We could then look for the overlap between where people get their drinking water from a location on a river, which would substantially change under deglaciation. And this is how we identified vulnerable communities. We found that there were a handful of critical places that were vulnerable in Alberta, including the towns of Hinton, Rocky Mountain House, and Lake Louise, but also the Bighorn Dam, which is the largest reservoir in Alberta and is located upstream of Edmonton, where over 1 million people live. As shown on the left here, normalized streamflow is on the x-axis, and deglaciation is represented by going from a solid curve to a dashed probability curve. And we can see that deglaciation leads to a significant reduction in terms of summer streamflow at these locations. We published this work in Nature Climate Change in 2020, but really recalling my goal, I wanted to reach these people who were buying and selling the narrative that climate or glacier models are wrong or uncertain and can't be used. And these might not be people who are reading this journal. So I engaged in a media campaign to try to publicize our findings more broadly. I did TV interviews on CBC and Global in Edmonton, Calgary, and nationally. I did print interviews in CBC Edmonton and the Calgary Herald. And the work was featured on the Weather Network, which was really fun because I love reading the Weather Network, so that was really cool. And I also wrote about my work on Facebook and Twitter, where my Twitter thread was actually read by members of the government in Alberta. And I also spoke to middle and high school classrooms in different schools around the province as well. Because I had this target audience of skeptics in mind, I tried to connect what I perceived their values would be. So I highlighted that we were using observations directly and not climate models. I spoke about how Alberta can be recognized as a leader and not as a follower when it comes to actions on these issues. And I highlighted the economic value of that action to preserve the glaciers. However, there was still a large and loud response claiming that climate models are uncertain or wrong, even though we did not use them. And there was this common refrain that scientists just keep saying the same thing over and over, and that none of this is new. The CBC piece alone got around 1,000 comments, many of them echoing these ideas, while other pieces received hundreds of comments together. And again, while some of these are certainly bots, many of them are not. And again, they are people and voters, and their views are reflected in government. In fact, there was a representative from the government of Alberta who responded to the CBC piece saying that there's nothing to worry about because we have dams and we have rain. And that, is in direct contrast to the paper where dams are vulnerable and rain isn't enough. And we show that directly. So it was really interesting, as well as being disheartening, to see these talking points that were entirely counter to my work and how I tried to communicate it. And since then, I've tried to think about why this may have happened. To better understand where some of these first comments about uncertainty and performance come from, I think we can look to the work of people like Jeffrey Supran and Naomi Oreskes at Harvard, who've written several interesting papers about the use of rhetoric and framing by fossil fuel companies, and in particular, ExxonMobil. One particular framing strategy is that of scientific uncertainty, that models or processes are just not well understood and that we just don't know enough to act. So companies actually spend billions of dollars to get this message out, and it's been really effective at delaying public pressure for action by shaping this public discourse. Here, I'm referring to this class of fossil fuel communication strategies as being propaganda, and I'm not using that word to be controversial or sensational. I'm really just using it to be consistent with the language that's used by academics who study these communications in detail. I think one result of this framing is that we as scientists, we see this uncertainty talking point, and one of our strategies to counter it is to work to reduce it. This, I know for me, has been a central motivation in a lot of my work outside of even what I've spoken to today, where I've been working to come up with more certain projections of stream flow in rivers across BC and Alberta. But one thing that I've really had to reckon with is that uncertainty will never be zero. And so I will never really be able to overcome this framing by trying to barrel through it. Upon some reflection, it's been interesting to realize that by trying to counter these ideas, I think I was allowing fossil fuel companies to shape my research trajectory because I was spending my time and my effort working through the lens that they were wanting me to. Taking a step back as well, it makes me think about those IPCC assessment reports that Rachel had mentioned, where each subsequent report does reflect a remarkable amount of exceptional and creative work, and the language around confidence is becoming more certain on so many fronts through time, yet this scientific uncertainty framing persists and it has remained effective. Next, on the take that, well, we knew all of this already, I learned that nuance can easily be lost in science communications and media, and that in fact, many studies do look the same to the general public. I'd like you to try imagining, the last paper that you were a part of, and how might you try to communicate about it if you had less than 60 seconds on TV, where that segment would be edited by somebody else, or there's a 500-word written piece, which would include alternate and competing perspectives, and where your audience doesn't have a science background. my point here is that it's just really hard to do. This is a challenging thing for anyone to do. And what we're taught in media training is to really boil down to the absolute essentials and to know your key messages and to stick to them. When we do that, we can compare these two studies, the first being Gary Clark's from 2015 about deglaciation in Alberta and our work from 2020 about local water resource vulnerability. These are very different studies with very different goals and very different methods. But at the end of the day, our main message that we deliver to media is really quite similar, that Canadian glaciers are rapidly melting and there's implications for downstream communities. Despite the science being very different, the message that we're delivering to the public can be a similar story over and over, and this has the effect of having people tune out. To summarize the outcome of some of my experiences, I first of all did not convince quote unquote skeptics by structuring my research around observations rather than climate models, nor did I sway this audience through deliberate messaging in media. And I've realized that my decision to center this audience was potentially seeded by messaging from fossil fuel companies. I think that this came at the cost of a potentially lost opportunity to cater my messaging to a more gettable demographic. You know, while I was pitching my results to reflect the values of what I thought skeptics might hold, emphasizing Alberta as a leader and the economic value of glaciers, I think that if I could do it again, I would appeal to a more moderate audience, emphasizing the role that fossil fuel companies were playing and highlighting the agency that individuals had as a collective. Second, I learned that it's easy to lose nuance in media communications. When we boil down to that essential information, many studies do look quite similar, and this repeated messaging can cause some in the public to stop paying attention. But thirdly, while I may have allowed fossil fuel propaganda to shape some of my research, we still ended up developing a new way of thinking about what was previously a very challenging and nearly intractable problem. So our approach really allowed us to get this first assessment of vulnerability to deglaciation at the local scale, which was really quite exciting. So even though we may have played into the hands of big oil to some extent, we did achieve something new. And overall, I'll consider this to be a mixed bag of results and lessons learned. To conclude, I don't think that we can dismantle, these propaganda machines, or we can't reinvent media, but we can be aware of the forces that are shaping the questions we ask in science, and we can be creative and use that to ask new questions. And we can also be intentional in how we're communicating to our audiences. So tailoring our messages to be received by audiences where they'd be the most valued. And so with that, thank you very much, everyone. I look forward to chatting and having some questions.
Yeah, thank you very much, Sam, for this very thoughtful presentation. We will entertain a question from the audience for you, and then we'll go to general questions for everybody.
Great.
Johan, go ahead.
Hey, Sam. Great talk. I just have a question about looking at the comment sections for judging or gauging the reception of your research on media. Did you look at any other possible metrics for how the public received your research other than that? Because I find that the comment sections for articles and whatnot typically are the most extreme viewpoints, often negative, and I'm not sure that they're necessarily a great way to understand how well your work was received. I wonder if actually you did change a lot of gettable minds, but I just don't know how to gauge that. Do you have ideas?
Yeah, that's a really great question. And I mean, I think I agree. It's really hard to measure who are you actually communicating to and whose minds are changed. I think for me, the challenge was just the volume of negativity still. So that was still an issue. One way that I've thought about how minds have or have not changed, I think was reflected in the response that I got from the government of Alberta, who reached out to have the paper and who went through my Twitter and then responded directly and were quoted in the CBC piece, saying that that my work was not true, and so seeing that was a more concrete example of real people who had power not be moved by the work. So I agree, it's challenging to measure how people are moved. And I'm not, frankly, totally sure how to measure these population scale perspectives, but I do know that there's a hard group of people to reach, it seems.
Yeah, thanks for that. I'll ask you a follow-up question, Sis. Once you got your message, what did you want people to like get out of this message? What should they do with that knowledge? What did you want the societal response to be?
Yeah, I was hoping for a response where people who have maybe changed their mind or had thought about deglaciation in a new way, I was hoping that they would reach out to either myself or to reach out to local government people, because this is water supply is an interesting issue in Alberta where it's run at the local scale. So it's communities that are managing their water, but there's a strong relationship among sub-regions who all depend on the same plant. And also they get a lot of funding from provincial governments to run those plants. And so I was hoping that there could be this cascading sort of messaging that would go up the chain from local people talking to the utilities managers who would talk to like going up and up and up that chain. And I was asked this question, in a lot of interviews, like, what do people do about it? And that's what I recommended. I said, reach out to the people who are managing your water, find out where your water is coming from and talk to them and ask questions. And so again, that's a hard thing to measure if it happened or to what extent it happened. But it's something that I do think about. I'm still not sure how to measure though.
Yeah, thank you. Thank you very much. Max, you had a question.
Thanks. Great presentation. Question about the specifics of the study. For like areas along that receive water from one specific area, like Hinton, why was, say, Hinton identified at risk versus not, say, Edson, if those are like somewhere downstream of that same water supply?
Yeah, thanks, Max. That's a really great question. So there's two different forces at play here. One is that we found that nearby communities can have very drastically different vulnerability just due to the fact that they get their water from different sources. So a place like Jasper, we found to be not vulnerable to the loss of glaciers because they don't actually get their drinking water from the Athabasca River. They get it from deep underground wells, which were hydrologically quite disconnected from the Athabasca. And so folks in Jasper are not going to feel the effect of glacier loss to the same extent that folks in Hinton will. And at the same time, the further downstream you go on a river, the less important glaciers are in terms of the raw number, or in terms of the volume of water that's coming from glaciers. And what I mean by that is folks in Fort McMurray, 1,000 kilometers away, a lot of the water in the river by that point is coming from groundwater sources. It's coming from rain that happens across the province. And so glacier melt is a less important constituent just in terms of the relative change that will occur to the river.
Cool, so that makes sense.
Question. Perfect.
Yeah, thanks.
Thanks, Max.
Thanks, Sam. We welcome questions for all three speakers at this point, but Mark, you had something to say.
Sam, that was a beautiful discussion of what you learned and how you've learned it, both in terms of disseminating a narrative as well as doing the work. Your end comment was to be intentional, and that's actually the goal of most media training strategies. But you also said that media training strategies are fairly generic in their approach, and so not very effective. So what's your message to doing the media training better or more effectively?
That's a great question, Mark. I think if I could go back, I would, first of all, target a different audience. And so when I'm talking about being intentional, I'm thinking about not just the communities who are not just communicating to the folks who are the furthest in opinion from you, but trying to think more critically about who are the communities that could be swayed the most. So that's one way I'm thinking about intention. But on the issue of how do you actually do that, I don't actually have a great answer. One of the things that I think is a problem is that when, in addition to the challenges of having similarly boiled down messages, actually, I'll back up. I think one thing that I would do if I could go back is I would try to emphasize uniqueness more, rather than finding the similar boiled down narrative that was, maybe it is at the heart of it. I would want to emphasize more the unique aspects and try to highlight those more in communications. One of the challenges that I didn't mention, I think, is that when we do TV or print interviews, we as scientists are, representing the institution of science. And so it can be just harder to have a conversation. And I think the more effective ways of communication are more casual and one-on-one, where you're not representing an institution, but where you're just a person. So my most effective conversations have been like with my uncle while we're doing dishes at Christmas, and not so much in these formal settings where we represent institutions. So that's hopefully partial answer to your question. It's hard. It's really, really hard.
At this point, do the other speaker want to try to answer that same question? Like, what do you think is some lesson learned about your media intervention and your media communication strategies? Rachel?
Yeah.
Oh, William, go ahead.
Go ahead, please.
Okay. Yeah, and so I did a fair amount of media communication over the last year about extreme events and climate change. And I think it was a slightly different audience because I was being contacted for statements. And by that point, they were sort of looking for someone to say, oh, this is definitely climate change. And so at that point, it was more of a being careful to explain some of the uncertainty and to be saying, climate change is playing a role in this. But what I didn't want to happen was for people to interpret what I was saying as like, oh, right, like the heat wave in BC is like the new normal for British Columbia, because it really shouldn't be. It might be one of our new extremes, but it's not the new normal yet. And then when we have a few years where we don't have any extremes, be like, oh, well, climate change obviously isn't a problem because that was the connection. And so I think Sam sort of mentioned something to do with as well as this level of uncertainty. And yes, that's been harnessed by the fossil fuel companies to say, if there's uncertainty, it means we shouldn't do anything. But a level of actually being able to articulate and communicate what uncertainty there is, that sort of intrinsically in the system, is important, but that's a very difficult topic to get across. And I think there is a lot of sort of even research being done about how to communicate uncertainty with the public in a scientific manner.
Thanks, Rachel. William?
Yes, thanks. No, I think both Sam and Rachel bring up a really good point. I want to take it to another perspective. Is that I think for some of the I'm more and more towards that, like for some of the more effective translations of the research to the public or the knowledge user, I think it is one of the effective way that I'm thinking and I'm trying to do more is the knowledge co-production through knowledge co-production. So what it means is that it is not just researchers doing the research and then communicate it to the public through the traditional means of through the media, but then actually engaging with stakeholder, knowledge holders and right holders at the very right beginning, trying to understand what the questions that they want to ask, and then using that to develop the research together with the community and with the stakeholders, where you can get a much more a better buy-in and from the get-go. I think, for example, the larger scale assessment has been trying to go towards such as the IPCC is trying to to move towards a little bit more on this. For example, when they scoop out the assessment report at the beginning, they would engage with all the countries, focal points and government representatives to understand what questions they want to answer in the assessment report. I think it can be the way that we start to think from the researcher point of view in many aspects of our research. I know there are still fundamental research that focus on discovery that we won't, I think it may not be applicable, but then a lot of the applied research that we are trying to actually provide information to support actions and policies may be suitable in this mode of research framework.
Yeah, thank you. That's very powerful. Francis, you had I should say that it's past 5 p.m. and everybody that wants to leave should feel free to leave. And we can entertain maybe 10 more minutes or 5 more minutes of questions. Francis?
Yes, great, thanks. I appreciate the combination of speakers and topics today. I have a couple of points and a question which kind of addresses all three. First, one of the challenges with this communication game is that you've chosen to address beliefs in your communication, and beliefs are very firmly fixed. I'll mention that in a second. Again, the other aspect from an educating point of view is that it's extremely difficult. It's well known to be extremely difficult to learn past a misconception compared to introducing a new conception. Even for very fundamental concepts, somebody who's got it wrong in the first place, you have a great deal of difficulty as a teacher or as a communicator to get past the misconception. If you know that, and you know that you're tackling misconceptions, then maybe your expectations can be slightly reduced and you maybe not feel so disappointed. Now, the actual question, which kind of relates to Rachel's list of potential research, one aspect that William mentioned was a lot of modeling related to nutrient availability and where it's changing and where it might change for different scenarios. I'm wondering if there's an opportunity yet, or perhaps now, for one aspect of research to focus on what I would call the ground truthing of some of the models and some of the concepts, whether it's stream flow or nutrient availability. Are we in a position anywhere, and I suspect that working with Indigenous communities is actually one approach to managing this question, but are we in a position to take some of these model results and go to communities that are in extreme situations, perhaps Arctic, some of our Arctic colleagues or communities, to actually test whether there's a apparent shift perhaps in micronutrients availability for Arctic communities, and whether these ground truthing notions could be the source of communication that Sam's trying to arrange. I mean, if you can do ground truthing to find a community where their groundwater level is dropping or where their stream flow has reduced, and to actually relate that directly to a glacier that's gone past the fern line and has basically disappeared, might be one approach which is research-based, but which addresses experiences rather than beliefs. And so I guess the bottom line is, do you think there are opportunities for researchers to get funding and to actually spend time looking for opportunities to ground truth? I think I'll shut up there.
Yeah, maybe I can start addressing that. I think this is a really good point, Francis, and that it is actually something that my colleagues and I are really interested in. Is first of all the developing new ways of bringing together these different lines of evidence, and some of it, as Rachel said, it may be from a different worldview, from different knowledge systems, and I think we still lack proper methods to actually how to bring these different knowledge together. I think both in terms of understanding past changes and then using those information to combine that with some of the use it along with other scientific methods such as model projections. And then another things that I also find very exciting is the recent development of the attribution science, where now that colleagues can use model projections combined with observations to be able to attribute quite effectively and quantitatively the relative contributions of different factors in driving certain events or impacts, and so that we can then more precisely identify what are the issues or the aspect that we actually need to tackle in order to reduce those impacts or reduce the vulnerability of the people or biodiversity. So those are the things that I agree, and I find that they're really exciting and something that I would like to engage in more. Thank you.
Thank you. Yeah, I can add that in my own polar research, we definitely do that. You know, we definitely go and see evidence of these changes. The problem is that once you see the changes, once the ecosystem has already changed, it's kind of too late. So there is a little bit of that aspect of it. But Dominique, maybe you have something to ask.
I was actually going to continue on sharing experience and then ask something. When we did our bee study, we got a lot of media coverage, and we had very, very good training by the people from UBC. And I would actually highly recommend they offer training for the department. And Sam, I don't know if you also were trained by Sashi. That was, I mean, we spent a whole day with preparing of what to say and especially what not to say. And I guess the lesson I got is that first, you don't approach that as a lecture, you speak simple and you're trying to put yourself in the shoes of the audience. What is it that they want? And it's not always easy. It's also a question of culture. When the paper on the Notre Dame, so there we were in France, and we were lucky to see a press release for the study of the souls by a scientist from Lamont, who happened to be the son of a French woman, but he got scorched, mostly being accused of imperialism, and that they should have gone their studies in the US instead of trying to trace pollution in Paris. So we said no comments, we don't allow comments, and people contacted us directly. And I think the conclusion we drew from that, or I drew from that, is that we need to come in there humbly and not think that the audience know less than we do, and trying to find a connection, a platform where we can discuss and share and potentially let them talk before we talk. I'll stop here.
Yeah, I suppose I'll comment and say that I totally agree with a lot of what you just said. I also did my training with Sachi, and it was so valuable. I'd really recommend it to everyone. It just is it's a really new way of trying to think about the work that we do, really flipping it on its head. And I agree, Dominique, with the point about how it's almost more useful, I think, when scientists can listen and have that way of communicating rather than telling people our stories. But it's hard to arrange that, and I'm just wondering, like, it would be so valuable as a department if we could have that type of format of discussion with members in the community, or some sort of system that would allow us to connect and listen to other folks as well. Because currently it's just hard to do in media generally.
Thank you, Sam. Dave, you had a question.
Yeah, it's similar to both Francis and Dominique. I've been giving talks for about 2 decades on global warming based on my own research. And I was under I think, the mistaken view that if the science is better and if the uncertainties are less, then the argument is more convincing. And I think that was wrong. I think that the mistake I made was not searching for the values of the audience. and speaking to the values of the audience. And they may be a secure life for their children, or it might be financial security, or it might be a food supply. And I think we need to take, whether it's glaciers, whether it's aquaculture and so forth, and try to speak to those values. It's not easy, but it's not something we're particularly trained for.
Yeah, I definitely, I agree. One way that I've heard it put as well by Dr. Catherine Hayhoe is she talks about how people don't need more problems. And so if we just shove another problem of climate change on them, like we all have enough going on that we can't have another hole in our bucket. But it's really looking at and trying to, yeah, exactly what you said, connect with the values that folks have and say climate change is already a part of the challenges that you have and the things that you care about, and making that connection rather than putting climate change on top.
Thank you.
Thank you for that. Philippe?
Yeah, thanks. It occurs to me that there will be some interesting lessons learned on the parallel challenges of communicating around climate change and vaccination. Similar kinds of issues, but different context.
That is what makes me very nervous, because vaccination is your life down the line in less than a year, and we still fail. So if climate change is like 30 years from now, maybe 100, and it's not exactly your life, I don't know.
But okay, I'll just follow up and say that a lot of the conversations I've heard from doctors I know and others working in this field sound very, very similar to the way this is being presented here. For example, don't even bother with the people that believe that there are microchips in vaccines and, you know, it's some global conspiracy. Look for that group in the middle and focus on those, what was the word, the gettable minds or whatever it was. So there are lessons I think that can be learned.
You're right.
Absolutely. And I also agree that like, we don't need 100% of people to be on board for us to have like pretty radical solutions to climate change. A majority of people believe that climate is a huge issue. And so we have the numbers. I'm not quite yet understanding how that like majority perspective is not translated into the types of actions that we would like to see. So it's interesting to think about as well.
Colin, you wanted to say something?
Yeah, just a follow-up comment on a couple of these things and then a quick question. One of the things that I really noticed in Rachel's talk, Rachel, when you mentioned the quote about Indigenous knowledge, one of the things that was in there was, and to me very important, was the collectively held knowledge that is community-based. And I just think this whole conversation we're having right now is about how do you make this knowledge collectively held? And I think you do it by communicating it amongst your community. And so it seems to me that a lot of this is about how do we make ourselves as scientists a part of our communities, and how do we make those communities a part of, or those people a part of our communities with all of the back and forth that entails. So I think that's a really interesting point that just touches on a lot of what you've all been saying. And I just wanted to follow up with a quick question that could apply to all of you, but it came out of Sam's talk. When you're dealing with this nuance in a story. So we all have seen projections of different things, whether it's projections of nutrient loss in the oceans, or whether it's projections of different levels of deglaciation. If you want to convey that nuance to a community in the way it says, how do you plan for that? Or how do your plans change given these two different scenarios, or do they? Does it matter how different those scenarios are given, say, limitations on their ability to adapt and mitigate? You have any comments on how communities have responded to those kinds of things?
Could you repeat, sorry, the question?
Sure. So if I'm a community in Hinton and asking you about your paper, and you say, okay, well, if we have two different scenarios, one is an extreme climate change scenario and one's a moderate scenario. In the extreme climate change scenario, you lose 70% of your typical water supply, but you lose 40% in the other scenario. How much does that difference matter to that community in terms of their ability to adapt and mitigate? does that nuancing that you're giving to them, how much is it actually going to inform their decision making and their ability to plan?
That's a really great question. So I think, I mean, as we saw in, I know some of William's slides with the low emissions versus high emission scenario, in a lot of cases, it's the largest variability is between emission scenario and less so the interannual variability in the system. And I think that one thing, so in many cases, yes, it does matter. It matters for infrastructure. It matters in terms of lifestyle. Those different scenarios will have large differences in outcome. And I think that one way that we can talk about that is maybe less so about percentage, like saying percentages when we're talking to communities, but I think a good strategy is to highlight that these lower emissions pathways lead to lives that are better. Like, we have more enjoyable lives when it's not 45 degrees. And we like, life is happier, and you can hang out with your friends when you don't have to walk so far to get your water, or if there's a power outage from extreme temperatures. And finding a way that we can explain these different scenarios in terms of a more optimistic future rather than it all being doom and gloom, I think is one of the important keys.
Thank you. I think in the interest of time, maybe I'll let each speaker give some closing comments, and then we'll just wrap up. Rachel, you had something to say, so maybe you can start.
Yeah, thanks. I just wanted to sort of add on to, and I think this fits in very well with a lot of what's been discussed here, of the idea of sort of not giving people another problem that they have to think about. And part of that, I think, is, well, what do we actually want people to do with this information? What are the solutions that they can actually do? And how does that intersect with their other beliefs, their other priorities? And so, yes, voting is one of them, but there are also other sort of community and collective decisions that do have impacts. And so again, I think from a sort of multi-cross-disciplinary perspective, sort of actually understanding what are the solutions? How do we encourage people to shift? And what are the sort of psychological and social sciences that we can use to understand how do we help people kind of shift their behaviors, rather than just putting it more information in front of them in isn't this going to be terrible? And then just leaving them with that sort of doom and gloom feeling. So I think, yeah, again, there's sort of working together and across multiple disciplines to understand how do we get people en masse to shift their behavior. And we don't necessarily need to focus on the ones that will never be able to persuade, but there are a lot of people who do think this is a problem, who would want to do something about it, but don't know what to do. And I think there's space there. So thanks everyone for this. It's been a really great discussion.
Yeah, focusing on actionable information is always more effective. Thank you very much for that. William, do you want to say some final thoughts?
Thanks, and just building on the last kind of line of thought that we have been talking about, one thing that we also have been trying to, the colleagues in the committee of scenarios trying to move forward is more on the focusing of the positive scenarios. So in terms of biodiversity and ecosystem services, for example, there's the new initiative of developing these nature futures scenarios, where it's focusing on desirable, sustainable futures that account for the pluralistic view of different people with different values, different perspectives that allow for this different view of the futures. And then the discussions, we hope that is to shift what are the pathways that we can achieve those alternative desirable futures. What are the necessary transformations in the society that is needed? What are the actions and the level that we need to pull in order to achieve that? So I think, and that can be operated at different levels, like from the local level, the national levels, and international levels. So I think that is one of the pathways that we can also change the narrative of the discussions. I'm not focusing on the negative side, on the gloom and doom, but then on the positive aspect and how we can achieve that. Thanks.
Yeah, thank you very much. Sam, do you want to say one last thought?
Yeah, I mean, one thing, this whole process of thinking about how fossil fuel messaging and propaganda has shaped the communities that I've decided to target and the questions that I've been asking has been a very strange thing to go through. And if anybody here is, interested and wants to talk further or discuss these ideas in the context of our own research, I would really, encourage folks to reach out to me. I would really love to talk about these ideas with more people and think about how we can use them not as, barriers to asking questions and to our research, but trying to use it as a springboard to ask new questions and to think about different and exciting ideas. So I am looking for community doing that. So if anybody is looking to chat further, please reach out. And also just a huge thank you to Rachel and William and the organizers for this session. It's been really, really fun.
Yeah, thanks you too. Colin, do you want to finish off with presenting what's coming next week?
Sure, we'll try to make it quick because folks have been hanging out for a while. So thank you everyone for still being here. So just a quick preview of what's coming up. So next week, two of our own students, Katrin Steinthorstottir and Birgit Rogala, have organized a session on climate solutions, particularly for mitigation, adaptation, and resilience. So we have a series of lightning speakers coming up next week. And then just to remind you what's coming up after that, we have a whole series that includes geothermal energy, balancing resource needs and sustainability and justice in mining, translating research into effective policy. And then finally, we'll have a session on how we as our scientists can communicate or can engage with our own community at UBC and beyond with what's happening right now outside our doors. Thanks, everybody. That's been great. Great discussion.
Thanks, everybody. Thanks to our speakers and to everybody that had really fantastic comments. And we look forward to seeing you next week.